So we've got sand or something falling onto a conveyor belt, and the speed of the conveyor belt is given. What is the momentum supplied? What is the kinetic energy supplied? What is the force on the conveyor belt, and the force needed to move the sand? So something like this. That's a little conveyor belt, and the sand's falling here, and it's sort of getting pulled along like that. I suppose you could make it like some little piles or something. So in 1 second, the momentum supplied is simply the mass per second, which is 18 kilograms, times 8. What's 18 times 8? Simply just mass times velocity. So that's 144. And the kinetic energy supplied, we simply work out the kinetic energy per second. So that's a half times 18 times 8 squared. Which is 576. Now, the force on the conveyor belt, let's think about that. Force is the rate of change of momentum, and that's something that we've just figured out. We literally just worked out in the first step the momentum per second. So that is 144 divided by 1 second. So the force is the momentum per second. And then to get the power of the belt, we use power is force times velocity. And that's going to be 144 times the velocity of the belt, which is 8. And that gives us 1152, which is double the kinetic energy per second. So it's an interesting question as to where the rest of that kinetic energy goes. We've got 1152 joules in, and some of it comes out as the kinetic energy. And what about the rest? I suppose that's for another video though.